Assalamu alaikum, welcome to this tutorial on LULC analysis in ArcGIS using Landsat 8 data. In this video, I will show you step by step how to perform supervised classification in ArcGIS to generate a land use land cover map. Whether you are a beginner in GIS or working as a professional project, I hope this video will guide you to understand that how can you prepare your satellite imagery for LULC analysis. How can you create sample and save your samples as a SHV or signature file? So let's get started. Okay, so first of all, I will open my ARC catalog and navigate toward my folder where I have my Landsat 8 data. And over here, these are my all bands. I download this image from USGS Earth Explorer Landsat 8 level 2, and this is the date of this image 2025-0912, and these are the band number 23456. So if you don't know how to download a Landsat product from USGS Earth Explorer, then you can click on top right corner. In this video I have showed that how can you download any Landsat product from USGS Earth Explorer. And if you want to know how these bands are different from each other, then you can click on top right corner. In this tutorial I have explained every band separately. So all you need to do, just import these bands from band 2 to band 6, 3, 4, 5 and 6. Now you can close this R catalog. So band 2 is blue, green, red wavelength, NIR wavelength, and this is the band of short wave infrared. Okay, so now this is the city of Cairo and we will make a composite of all these bands. So for this you need to open your search tool and search for composite. Or here composite band tool, just open this tool and drag your all bands over here in order from 2, 3, 4, 5 and 6. Make sure this order and then hit OK. Okay, so after 1000 year letters, you have your band composite. And I think we don't need this band in my table of content. You can remove these bands from over here. Now, this whole tile of Landsat 8 is too big. So we want to work on our area of interest. So this is the city of Cairo in English. And we can clip this with any shapefile, and if you want to do a quick raster clip, then you can use this image analysis. Just select your image from over here and this tool will clip your image with this bounding box that is actually the canvas of your screen right now. And if I will hit this tool, then this will clip that image just like this to that your previous canvas and save this image temporarily into your table of content. And if you want to permanently save this image, then you have to export this data as a TIFF file. So here I have already clipped the image much smaller than previous canvas, so we can do our LULC analysis quickly. Okay, so now in this LULC analysis, the main concept is band combination and their visualization. That how can you visualize vegetation and built up and water bodies like these features on this scene. So I just take 2 to 6 band of my Landsat image and stack them into a composite. Now I have 1 to 5 bands in my composite. One band is actually that second band, blue, green, red, NIR and shortwave infrared. If you want to see this image into a natural color, then 3 to 1 will be that combination. Like red band will be in red color, green band is already in green color, and first band, that is blue band, will be in blue color. Now this is actually a natural color composite which look like what our eye sees. And similarly 4, 3 and 2. So right now I am visualizing, we can't see NIR wavelength, but now I am visualizing that band into red color and third band into green color and second band into blue color. So this composite is known as false color composite, where vegetation appears red because plants strongly reflect near infrared or NIR light, and in this combination NIR band is displaying in red color. So that's why these red color are vegetation and plants. Similarly, for water, we can make a composite like 4, 5 and 3. So right now water is right over here in black color. This is useful for the visualization of water bodies because water absorb NIR and shortwave infrared energy. So that's why it's appear black, because it's completely absorbed these wavelengths. So for your better understanding, I was working on these samples. I have made a graph. Like over here you can see that we human eye can only see blue, green and red colors. So vegetation, why plants always appear green to us? Because they reflect green light more than blue and red. Blue and red light are actually they are using for photosynthesis, and about 8 to 9% of green light they reflect back. So that's why our eyes sees plants in green color. But when this NIR wavelength or NIR light hit a plant, then it reflect approximately 48 to 50% of that light. So that's why plants strongly reflect NIR wavelength. And then similarly for water, water is actually is in blue color line, and water reflect green light, blue and red lights. But in NIR and SWIR, it completely absorbed. That's why in NIR and SWIR water appear black. And right over here, this is the curve of built up area, and built up area can be identified perfectly in SWIR because built up or cemented area reflect SWIR shortwave infrared strongly. And for snow, you can see right over here, it's appears so bright, too bright, that in blue, green and red color, it reflecting light approximately 90%, 85 to 90%. This is actually a simple concept. So what is the behavior of sunlight with different features on Earth's surface? Now for image classification, let's make a combination of 4, 3 and 2 and hit a right click over here. Open your image classification tool and make sure that you have select this image in this panel. And now we will open this window. We will collect all samples into this window. So first of all, I will take the samples for water body. So for water body, I think best band combination is 4, 5 and 3. With the help of this tool, you can draw a polygon just like this over water, just like this. And when you will hit double click, then this sample will save right over here. And you can also make a rectangle just like this. This sample is also now available over here. And if I will click this, then you can see that this polygon is now selected, and if I will hit this, then this polygon is selected. And if you want to delete any collected sample, like I just make a sample just like this, and I think I have the pixels of vegetation, then you can select that sample from over here, or you can uh, press the shift button and you can select two polygons, and with the help of this tool you can delete these samples. Now let's gather some sample for water body, just like this, just like this, this and this and this. And over here you can change this tool to draw polygon, and you can collect the sample just like this. So you can collect water bodies samples just like this. So once you are done, it is recommended that you have to collect about 50 to 100 samples for each class. So right now I just gathered 14 samples. Okay, so now I will merge all these samples. Just select from over here and press shift button and select 14, and with the help of this tool merge all these training sample. So these all training samples are belongs to water. So I will rename this class to water, and you can change the color to the blue. So right now this is the value, and this is actually the count that how many pixels you have collected under your samples. It's about 3 or 2. Just like this, if you want to collect sample for your vegetation, then you have to change the combination to 4, 3 and 2. So right over here, what we can do, we can make two classes of vegetation. One is vegetation, dense vegetation or cropland, and other will be sparse vegetation or light vegetation. So first of all these strongly red color are actually dense vegetation or cropland. So you can make a polygon above all these just like this. All these red color are actually the healthy and dense vegetation, just like this, just like this. So I can't collect. So right now you just see that I have some other pixels that are not red. So these pixels are actually not the pixels of vegetation, so you have to delete these pixels. Just select this polygon and hit delete button, and again select make a polygon over your red pixels just like this. So I can't make 100 pixels of all these classes. I already collected all these samples for you, so this is just for your learning purpose. And now let's suppose you have collected all 100 or more samples for dense vegetation. Then select all these samples and then again merge them. If you want to delete only one sample, then all you can do, like I have merged all these sample, and after merging your sample you just see that this sample is not correct. All you can do, just select this, and with the help of this tool split training samples, and now just check this color, select this color, and this sample is now selected. You can again delete this sample. So right now just merge these, and you can say to dense or healthy vegetation and change its color just like this. Now we will collect samples for sparse or light vegetation. All these light red colors are actually belongs to sparse vegetation, that is not dense. So you can collect all these samples just like this. If you want to cover these 3 pixels, then you can make a polygon above it, like just like this. So just like this. What is the rule of collecting sample? You have to collect about 50 to 100 samples, but that sample will not only from one side. They should collect it from everywhere of the of your image. So right over here, just collect this one. So once you are done, let's suppose you have collected the samples for vegetation. Just merge this and you can say this to vegetation, change its color to light green, and now we will collect samples for built up areas. So first of all these hazy things, all these hazy pixels are actually belongs to built up areas. So you can collect samples just like this. Even these bright pixels are actually the pixel of built up areas. You can make a polygon right above them, and all these, even this one is a built up area. And if you want to confirm, if you want to have a confirmation that is this area is built up, this can be a concrete feature. So you can visit your area of interest into Google Earth Pro, and here this is the city of Cairo, and I think we are on this bar, and we just collect sample from over here. And yes, this is the built up area. Even this bridge is a built up area, so you can make a polygon right above this bridge, just like this, just like this. Just like this. All these shiny and hazy colors are actually built up area. Just collect these training sample from everywhere of this image, but their count should be in between 50 to 100. Even this is the road. These are the roads. Roads are actually are also a built up feature. So let's suppose you have 100 samples of this built up areas. You have covered all these pixel, like over here. This is a built up area. This is also a built up area. This is a built up area. Even this is a built up area. And right over here, you can collect the samples from over these pixels, even from these pixels, even this bridge. So let's suppose you have collected 100 samples of built up area. Just select these samples and merge them and rename to it a built up, and change its color to red, just like this. And now we will visualize our bare land in this scene. So for this, I think 3 to 1 natural band combination will be a good idea, will be a good option. So these brown these brown so these brown areas are actually bare lands, just like this and just like this. This is a built up area. These green color are actually the plants, and then this is a bare land area. This is also bare land. And if you want to do the confirmation, then you can visualize your area of interest from over here, just like this. I have collect sample from over here. So this is a bare land area, and just like this is bare land. This is also bare land. This is also bare land. Okay, this is also a bare land. And This is also a bare land. This is also a bare land. Samples. Just open this window and merge all samples into bare land. So now once you have collected your samples, then store your samples into a format. You can store these samples into two format, into SHP. Like if you want to save the sample into SHP, then just hit this save training samples, and from over here just uh, give it to a name second and save these samples, because right now these samples are temporary store in this window. So you just save your samples. So if you if you ever lost your sample or crash, if you have a if you faced any crash in ArcGIS, then your samples are safe and you can load your training sample from over here. And this is the shapefile that we have recently saved. Just add this and now you have your training samples again on your windows. Now you can also save these samples into another format that is known as GSG signature file, and you can save it into your desktop, my samples, and its extension will be .gsg. Just save it and check your window. So this is your samples .gsg, and if you want to load yours, and I will show you that how can you use your signature file for image classification. So just open this window and remove these samples. I will load my own samples that I have collected recently. So these are my samples that I have collected from this image, for this image. Like I have collected these areas for bare lands, these area for bare lands, and this is, I think, can be a park or ground for for vegetation. This veg is actually light vegetation and this dense vegetation. And so I have approximately right now I have collected 3 to 6 pixels for my water body, 1350 pixels for my built up areas. Right over here you can see that I have collect a sample from where this bridge and for this built up area. So now you have, once you have your training samples, all you need to do, just open this classification and hit interactive supervised classification algorithm. After hitting this, this will make this will generate a raster that will show you that built up area is in red color and land is in this brownish color. And if you want to do a comparison between your this raster and your this composite, then you can use your image analysis window. Just select this raster and use this tool, swipe tool, and after selecting this you can check, like right over here, this color is actually for water, so we will choose a blue color, just like this. Just swipe this, so you can see that this red color is actually showing built up, and then blue color, and then vegetation. Let's change the band combination to 4, 3 and 2. Now check for vegetation. So with the help of this tool you can do a simple comparison. So right over here, this is the built up area and then vegetation, and just like this built up area, vegetation, and we can also visualize this scene from over here. So vegetation, built up area, and vegetation, and right over here vegetation, built up area, and vegetation. So you can see the change between these classes, like dense vegetation and vegetation and built up area. What you can do, you can reclassify this raster. Just open your search tool and type reclassify, input your raster, and first 0 1 2 3 4 and just hit OK. Now we just reclassified our this raster dataset. So 0 is actually blue color, and then this one is actually red color, and this one actually length is and this cancellation is and this is light relation, so the same. Now we will see that what is the purpose of GSG file. Now if you want to use this tool, maximum likelihood classification, now this window will be open and input will be your band, that composite raster, and here you have to input your signature file. So when you will add your .jsg file, just navigate toward your that file and select that file and hit OK. Then you will have the output of this algorithm in your table of content, and you can again reclassify that raster and so on. So just open this tab and you can even remove these training sample from over here, and just open your window and right over here raster to polygon. You can on so raster to polygon, just select this tool from over here, and input will be your this raster data and hit OK. So now you just convert your raster data into vector data, and if I will open its attribute table, then you can see over here I have a field with the name of grid code. Actually this grid code is belong to these classes. So 0 is actually representing a water polygon, and you can dissolve, you can use a dissolve tool to simplify these polygon. Just input will be your this vector data, and just select this grid code from here and merge all polygon with respect to their grid code. Okay, so now you can apply symbology to these polygons. Just have a right click on your polygon and go to symbology, select categorization, and your field value will be grid code and add values. So 0 will be your water body, and 1 I think belong to built up, and second is for land, and I don't need outlines. Outline, just hit OK. Now this is actually LULC, land use land cover view of this composite. All you can do, you can calculate the area of each class. You can calculate your area in your unit, whatever you want, with the help of this field calculator. Select these features. Now you can create a map of this LULC. just hit layout by adding a layout and these legends and northing arrow, etc. So now in next tutorial I will show you that how can you perform a accuracy assessment on this analysis. Like, you download a image, you did an analysis of LULC, but how accurate your LULC analysis is. So in next tutorial we will see that how can you do accuracy assessment analysis on your output. So many thanks for this tutorial. Take care. Allah Hafiz.